Between 1971 and 2014, the sea around these islands rose faster than almost anywhere on Earth. Nearly 4 millimeters a year, roughly twice the global average. About 15 centimeters of water added to an ocean that already surrounded everything. Over exactly the same 4 decades, the country got bigger. 73.5 hectares of new land, a gain of 2.9%. 8 of the 9 atolls grew. Neither figure is a guess. The sea level comes from a tide gauge at the capital, read continuously for half a century. The land figure comes from aerial photographs and satellite images of all 101 islands, measured across more than 19,000 lines drawn from shore to shore. The water went up, the ground went out. And across those same years, the people standing on that ground stopped being able to drink from it. The wells turned salt, the garden pits turned salt. On the main island, the groundwater was ruled unfit for use at all, so the land grew, and it became less able to hold a life. What kind of ground does that? This is Tuvalu, 9 islands scattered down 900 kilometers of the Central Pacific, halfway between Hawaii and Australia. 6 true atolls and 3 reef islands, with more than 100 smaller islets threaded around them. Add every scrap of it together, and you get 26 square kilometers, 10 square miles, the 4th smallest country on the planet. Around that land sits an exclusive economic zone of nearly 750,000 square kilometers. For every square kilometer of ground, more than 28,000 square kilometers of ocean. There are no rivers, not one. Nothing on any island is high enough or wide enough to gather a stream. The highest natural point in the country is 4.6 meters above the sea. It sits on Niula Kita, the smallest island of all. Most of the land is closer to 2. 10,643 people were counted here in the last full census. 2/3 of them live on a single atoll, and the ground they live on is not rock. That is the part the maps never show you. There is no bedrock under Tuvalu, not within reach, not within 100 meters, not within 300. What is under Tuvalu is the accumulated skeleton of living things, stacked for millions of years and still being added to today. The land here is not a place, it is a process. And to understand why anyone lives on it, you have to start with the animals that made it, and the ones that never left. On the outer islets after dark, something moves through the leaf litter that should not exist on land. The coconut crab, Burgus latro. In Tuvaluan, Uwu. It is the largest land invertebrate on Earth. A big one can span a meter from claw tip to claw tip and weigh 4 kilograms. Its front pincer can close with enough force to break open a coconut husk, which is where the name comes from, and which almost nothing else on these islands can do. It has abandoned the sea almost entirely. Its gills have been rebuilt into a chamber that works like a lung. It breathes air. And if you hold an adult coconut crab underwater, it drowns. But it cannot leave the coast. The female carries her eggs on her abdomen until they are ready. Then she walks to the edge of the reef, waits for the tide, and drops them into the ocean. The larvae that hatch are marine. They drift for weeks. The survivors find an empty shell, crawl out of the water, and start again. A creature that has spent millions of years becoming a land animal, and still has to return to the sea to have a future. That is not a curiosity. That is the logic of this entire country, worked out in a single species. The capital sits on an atoll called Funafuti. From the air, it reads as a ring, a thin, broken circle of green around a lagoon that measures roughly 24 kilometers by 18. 33 islets in that ring. All of them together come to 2.4 square kilometers of land. which means the atoll is more than 99% water. The largest islet is Fongafale, and Fongafale is where the country is. It runs 12 kilometers from end to end. At its widest, it reaches 400 meters. At its narrowest, 10 meters. You can stand in the middle of the island and throw a stone into the open Pacific on one side and the lagoon on the other. On that sliver live around 6,600 people. There is one road. It runs the length of the islet because there is no other direction for it to run. Houses sit on both sides of it, and behind the houses there is usually nothing but the shore. The ocean side is rubble and rough coral, taking the swell straight off deep water. The lagoon side is sand, calm, shallow, warm. Two completely different coastlines, 400 meters apart, sometimes 40. The reason for that difference is the reason the island exists at all, but we will come back to that. What people notice first is the water that arrives without a wave. On the highest tides of the year, in the months around February, pools appear in the middle of Fongafale. Not at the beach, in the middle. On the road, in the gardens, on the sports ground, in the space between one house and the next. The sea does not wash in over the edge, it comes up from underneath. Children float on the flooded road on scraps of board. The pools sit there for hours, then drain away, and the surface dries, and nothing about the island looks any different. The ground is porous. That is the whole explanation, and it explains almost everything else that follows. Coral limestone is not solid stone. It is a fossil reef riddled with the shapes of the creatures that built it, connected pore to pore all the way down. Seawater moves through it the way water moves through a sponge. When the tide rises against the outside of the island, it rises inside the island at the same time. You cannot wall that out. A seawall stops a wave. It does not stop a water table. In 1898, on this islet, a group of men drilled a hole into the ground to find out what the island was made of. What they pulled up changed how the world understood every atoll on Earth. But the answer they found also took another 50 years to confirm, and we will get to it, because it is the answer to the whole question. Stand on the lagoon shore at Fongafale and pick up a handful of the beach. It is white, coarse, and heavier than it looks. Under a hand lens, it stops being sand and becomes wreckage. Broken staghorn, chips of plate coral, ribbed fragments of shell, small pale discs and small pale stars. There is no quartz in it, no granite, no mineral grain worn down off a mountain, because there is no mountain, and there never was one within 1,000 kilometers. Every grain of this beach was made by something that was alive. So the obvious question is the one almost nobody asks. If the land is made of animals, what makes it faster than the sea can take it away? The lagoon itself is called Tenamo. It is a drowned crater, though not the crater of anything that erupted recently. Somewhere far below it, there is the sunken summit of an old volcano, and the ring of islets is standing on the rim of that summit like frost on the edge of a glass. The lagoon is deep enough for ships and calm enough to anchor in, which is why the capital ended up here rather than on any of the 8 other islands. 7 natural passages cut through the reef and let water in and out. And the reef around it is doing the work that keeps the whole ring habitable. On the ocean-facing edge, the coral grows in a pattern of ridges and channels running perpendicular to the shore. Solid fingers of reef with grooves cut between them. Swell arriving off thousands of kilometers of open Pacific hits that structure and shatters against it. The grooves funnel the broken water back out. By the time anything reaches the shallow flat behind, most of its energy is gone. That is why the ocean side is a rubble beach and the lagoon side is fine sand. Same island, same storm. Two entirely different amounts of force arriving, filtered by a living wall the island grew for itself. There were more islets on the western rim once. There are 6 protected ones out there now, and one of the names on the old lists is no longer attached to anything above water. "300 kilometers north, there is an island called Nanumanga. It is not an atoll. It is a reef island, a compact piece of land with a fringing reef and no proper lagoon, just a small brackish pool inland and about 20 hectares of mangrove around it. Fewer than 400 people live there." For generations, Nanumanga carried a story that outsiders filed under folklore. The elders spoke of a large house under the sea. In 1986, divers went looking for it. 30 meters down off the northern shore, they found caves. Inside the caves, they found blackened walls, charcoal, and burnt material. Fire does not burn 30 meters underwater, which means that when someone lit those fires, the cave was dry. And which means the sea was once far lower than it is now. Picture it. The ocean stands tens of meters below where it stands today. The reef that is now a shallow shelf is a cliff. The cave mouth is a dark opening in a limestone wall, well above the waterline, and there is dry ground in front of it. Someone walks in out of the wind. They build a fire against the back wall. The smoke stains the rock. Then the ice sheets melt and the ocean climbs, and it keeps climbing for thousands of years, and the fire and the cave and the shoreline all go under together. The people here did not invent the idea of a moving sea. They have a story about it. It is older than any measurement anyone has taken. And the reef answered that rising water by growing. It has been doing it ever since. Further north sits New Tau, which has no lagoon at all, only reef terraces cut into the ocean-facing rock and shallow pools where the waves break over the edge. It is one of the oldest continuously settled islands in the group. South of the capital lies Nukulele, an oval of at least 15 islets around a shallow lagoon, where a stone called Te Whaleatua, the House of the Gods, still stands on the islet of Niuoka, beside a village that people left before Europeans ever charted the place. Now take the hardest problem this land presents, and watch what people did about it. There is no soil here worth the name. The ground is crushed coral. Shallow, coarse, and so porous that rain falls straight through it. It is strongly alkaline. pH readings run as high as 8.9, which is closer to baking soda than to garden earth. It holds almost no nitrogen and almost no potassium. Iron, manganese, copper, zinc, the trace metals every crop needs, are barely present, because the parent rock is not rock. It is calcium carbonate, and calcium carbonate contains none of them. Add to that, no rivers, no streams, no springs, and a country where 2.5 to 3 meters of rain fall every year and vanish into the ground within minutes. The vegetation reflects that exactly. Cultivated coconut woodland covers about 43% of the land in Tuvalu. Native broadleaf forest covers 4.1%. The coconut palm is here because it is one of very few large plants that will tolerate salt spray, alkaline ground, and a root zone that drains almost instantly. Its seed floats, survives weeks in seawater, and germinates where it washes up. Pandanus does something similar, throwing down prop roots that hold in loose sand. Between them and a handful of salt-tolerant shrubs, that is the flora of an atoll. Not because nothing else would grow here, because nothing else can arrive here, survive the crossing, and then survive the ground. By every ordinary measure of agriculture, nothing should grow here beyond a coconut palm and a pandanus. And yet, for at least 2,000 years, people on these islands have farmed a crop that needs standing fresh water. It is called pulaka, giant swamp taro, Certasperma mercuzii. On some islands, it will stand 4 meters tall, and a single corm can run a meter long and weigh close to 100 kilograms. It is a swamp plant. It wants its roots wet. There is no swamp. So they made one. Somewhere under every one of these islands, there is a lens of fresh water. Rain soaks down through the coral and does not mix with the seawater beneath it, because fresh water is lighter. It floats. It sits there as a shallow dome, thickest near the middle of the island, thinning to nothing at the edges. And it rises and falls with the tide like a raft on a swell. You cannot see it. You cannot dig a well and expect to find much of it, because on a narrow islet there is very little to find. But you can go down to it. By hand, with digging sticks and baskets, and a great deal of time, families cut pits straight down through the coral until they reached the water table. Then they kept going, widening the floor, banking the spoil around the rim. A well-made pit is not small. Some run 400 meters long and 40 wide, with earth walls thrown up around them and the crop standing in the wet floor below. And then they built soil, because there was none. Coconut husk, leaf litter, cut pandanus, ash, animal waste, seaweed, whatever could be carried. Layer after layer, year after year, until the floor of the pit held enough organic matter to feed a plant. Some pits have been fed like this for centuries. The crop is slow, 2 or 3 years before a corm is worth lifting. For the largest corms, the ones grown for a funeral or a wedding or a visiting community, far longer than that. A plant left standing for a decade or more, tended by people who will not be the ones to eat it. That is what agriculture means on an atoll. You dig a hole to a layer of water you cannot see, you fill it with soil you made yourself, and you plant something for your grandchildren. The pits on the main island are mostly finished now. Conductivity readings from the pit water at Funafuti come back between 4 and 5,000 microsiemens per centimetre. The threshold where pulaka stops thriving is well below that. The lens under Fongafale is thin, the island is narrow, the tide pushes salt into it from both sides, and the crop cannot tolerate what it has become. So the pits sit open, some of them full of rainwater and rubbish, and the food arrives by ship instead. Rice, tinned meat, flour. Something built by hand over 2,000 years stopped working inside 2 generations. Not because anyone stopped digging. Remember the pits. The reason they failed is not the reason most people assume, and it is the same reason the wells failed, and we will come back to it when we look at the 3 islands where it has not happened yet. Out on the reef, meanwhile, the ground is still being manufactured. Go into the water on the ocean side, and you will hear it before you see it. A dry, irregular crunching, carrying through the water from every direction at once. That is parrotfish, eating the island's future. Parrotfish have teeth fused into a beak, and behind the beak, a second set of grinding plates in the throat. They are not eating the coral for the coral. They are after the algae growing in and on it, and the simplest way to get at it is to bite the rock. So they do. An excavating parrotfish takes a chunk of living reef, crushes it in its throat, strips the organic matter out in its gut, and passes the rest. The rest is sand. A single large parrotfish can process hundreds of kilograms of reef a year. On atoll reef flats, where this has been measured carefully, parrotfish account for the overwhelming majority of new sand-grade sediment. On some flats, the great bulk of everything produced. Which means the beach on the lagoon side of Fongafale, the one people walk on and build on and bury their dead above, arrived there through the digestive tract of a fish. That is the answer to the handful of sand. Some of it is parrotfish. Some of it is something even smaller, which we will come to. The islands are not sitting on the reef. They are being paid out by it, grain by grain, and the reef has to stay alive to keep paying. Not every island in Tuvalu speaks the same way. On Nui, the language people use day to day is not Tuvaluan. It is closer to Kiribati, a Micronesian language, from a group of islands that sit to the north across open ocean. Tuvalu is a Polynesian country. Its ancestors came from the other direction, out of Samoa and Tonga, roughly 2,000 to 3,000 years ago, in double-hulled canoes navigating by stars, swells, cloud, and the flight lines of birds. The name itself means 8 standing together, for the 8 islands that were inhabited when it was chosen. And then there is Nui, sitting in the middle of it, speaking the language of the north. Ocean does not divide these islands, it connects them, and it does not care about the direction anyone intended to travel. The currents and the trade winds run through this part of the Pacific in ways that make some journeys easy and their reverse almost impossible. A canoe blown off a route from the northwest will make landfall here. A canoe from Samoa will make landfall here. Over 2,000 years, everything that drifts ends up somewhere. And this is the somewhere. It is not a theory. In May of 1861, a deacon named Elekana set out from Manihiki in the Cook Islands, was caught by a storm, and drifted for 8 weeks. He came ashore at Nukulaile, more than 2,000 kilometres from where he had started, and the church he began there is the church most Tuvaluans belong to today. People have arrived at these islands by accident for as long as there have been islands, and people have left them deliberately for longer than anyone assumes. That part comes later. Two years after Elekana landed, ships came looking for something else. Between 1862 and 1865, Peruvian vessels combed the Pacific for labor to work the guano deposits on the Chincha Islands. In 1863, they reached the southern islands of Tuvalu. At Nukulaile, islanders were called aboard under the pretense of trade and religious instruction. At Funafuti, the raiders took most of the working-age adults. Around 400 people were taken from the 2 islands. Nukulaile had been counted at about 300 people 2 years earlier. Fewer than 100 were left. Virtually none of them came back. Most died within months of reaching Peru, of overwork and of disease. It was kidnapping, and the men who did it were slavers, and no other word covers it. What remained on those 2 islands afterwards was the very old and the very young, a community with its middle removed. The geography made it efficient. 9 small islands, each with a few hundred people, no high ground to retreat into, no interior to hide in, and no way to warn the next island. The same isolation that had kept the group safe from almost everything for 2,000 years made it the easiest possible target when a ship with a hold arrived. "80 years later, a different set of ships arrived, and this time they came to build. In 1942, the United States established a base on Funafuti. In the space of a month, a detachment of naval construction troops, 2 officers and 120 men, cleared and compacted an airstrip 5,000 feet long on Fongafale. Within a year, it had been widened and extended to take heavy bombers. To find the material, they dug 10 borrow pits into the islet and hauled the coral out of them. Roughly half of Fongafale, as it exists today, is fill. The cost was counted at the time. Across 3 islands, the construction destroyed 55,672 coconut trees, 1,633 breadfruit trees, and 797 pandanus. On an atoll, those are not trees. They are the food supply. Coconut for water, oil, and flesh. Breadfruit and pandanus for starch. Along with the pulaka pits that were filled in to complete the runway, that is most of what an island eats. And the runway has never stopped telling the island what it is made of. The strip sits on reclaimed swamp, packed with loose, highly permeable coral blocks. Seawater moves through that subbase with the tide, freely, the way it moves through everything else here. On spring tides, water pools on the runway. Not runoff, not rain. It arrives through the pavement from below. Resurface it, and within months, the new seal blisters, vents, and heaves, lifted from underneath by water and pressure that no amount of asphalt can argue with. Which is the answer to the pools appearing in the middle of the road? The island does not have a flooding problem at its edges. The island is permeable all the way through, and always has been. That was never a defect. On a landform designed to let the ocean pass through it, it is the design. What changed is that people started building things that need the ground to hold still. During the war, most of the Tuvaluans living on Fongafale moved south to a smaller islet called Funafala and took the hospital with them. They stayed there until the base closed, then came back and rebuilt on ground that was no longer entirely theirs in shape. Out on the western rim of the atoll, on an islet called Fualopa, there is a sound the main island lost a long time ago. Black noddies, Anus minutus. Thousands of them, nesting in the pandanus and the coastal scrub, close enough together that the branches move. They are small, dark terns with a pale cap, and they feed far out at sea, following schools of tuna and taking the small fish driven up to the surface. They can be 40 kilometres offshore at midday and back on the same branch by dark. And for the navigators who found these islands, that daily commute was the instrument. Open ocean gives you almost nothing to steer by, but seabirds that nest on land and feed at sea leave a readable trace. Out at dawn, back at dusk, always along the same bearing. A canoe crew watching the evening flight of noddies and terns could hold a course towards land that was still hours below the horizon. Land was found here before it was seen. The birds reported it. Three islands in Tuvalu still have groundwater worth drinking: Nukufetau, Vaitupu, and Nanumea. Everywhere else, the fresh water comes off a roof. Rainwater harvesting is not a supplement here. It is the water supply. Gutters run off every roof on every island into tanks, and what falls in the wet season has to last through whatever comes next. The reason those three islands are different is the reason the Pulaka pits worked, and the reason they stopped working. And it comes down to one measurement: how wide the land is. The freshwater lens is a dome floating on salt water. Its thickness depends almost entirely on how far it is from one shoreline to the other. Widen the island and the dome deepens in the middle, far more than the extra width would suggest. Narrow it and the dome flattens until there is nothing but a film. Nukufetau, Vaitupu and Nanumea have islets broad enough to hold a real lens. Fongafale, at 10 to 400 meters across, does not. So the same country, made of the same coral, under the same rain, has islands where you can sink a well and islands where the well is salt from the first bucket. The land did not decide that by height, it decided it by width. And a lens that thin has no reserve. In 2011, and again in 2023, the rain simply did not come. Tanks emptied. Water was rationed by the bucket. Families moved in with relatives who still had something in the tank, and desalination units were flown in to make up the difference. A country that receives 3 meters of rain a year can run out of water in a month. Because the rain is not the problem. Storage is. And on ground that will not hold water, every drop you intend to drink has to be caught before it lands. Which brings us to a decision made in 1946 by people who had done this arithmetic long before anyone else was doing it for them. Vaitupu is the largest island in Tuvalu by land area. Broad, with a decent lens, and by the 1940s, crowded. The population had grown past what the pits and the reef could comfortably carry, and there was nowhere on the island to expand into. There is never anywhere on an atoll to expand into. The land is the land. The magistrate on Vaitupu was a man named Nelly Lifuka. Born there in 1909, sent to school on the island, then out to sea as an engine room hand on a phosphate ship, then back again. A man who had seen what other kinds of island looked like. He organized a collection. Money came in from families across Vaitupu, much of it earned working alongside American forces during the war. In June 1946, with those funds, the people of Vaitupu bought an island. Not a reef island, not an atoll. They bought Kioa, a mountain off the coast of Vanua Levu in Fiji. High ground, volcanic soil, streams that run all year. October 1947. A vessel called the Avahu comes into a bay on the eastern side of Kioa on a Sunday afternoon. 37 people are aboard, and between them they have brought about 15 pounds worth of food. There are no buildings. There is a beach, deep water close to the shore, and a fringe of palms. They go ashore and they start. Within 10 years, more than 230 others had followed them. Nelly Lifuka joined the community himself in 1956 and became chairman of its council. He died there in 1980. Nobody in 1946 was talking about sea level. The word climate did not enter into it. What entered into it was a piece of land 26 square kilometers in total, divided 9 ways, with a growing number of people standing on it and no way to make any more. The people of Vaitupu looked at that arithmetic and bought a mountain. That is the thing most easily missed about this place. Leaving is not a new idea here. Neither is staying. Both have been on the table for as long as anyone has counted the coconuts. Off the entrance to Vaitupu's lagoon lies a small islet called Tofia, sitting exactly where the ocean chooses to put down what it is carrying. An island built out of a sandbar that the sea keeps feeding. At the far north sits Nanumea, where a channel was cut through the reef during the war so that boats could get in, and where the founding ancestor is remembered as a man who arrived from Tonga and had to guess the names of the 2 women already living there. And at the far south, the smallest island in the country. Niulakita, 40 hectares, a single reef island with no lagoon. It holds the highest natural ground in Tuvalu, 4.6 meters above the sea. That figure gets repeated in every atlas and almost every article, usually as the punchline. The highest point in the country is lower than a house. But look at what the number actually did. Niulakita was uninhabited for most of its recorded history. It was worked for copra, visited, claimed, and left again. People only settled it permanently in the last century, resettled from New Tao, which was running out of room. The country's high ground was empty for centuries. Not because 4.6 meters was too low, because 40 hectares was too small. Everyone outside this place measures these islands vertically. The people who live on them have always measured them the other way. Nearer the capital, two islets on the atoll rim, Amatuku and Matugi, have been among the fastest growing pieces of land in the country, gaining ground steadily through the same decades in which the sea has been rising against them. And around all of it, that enormous ocean. Nearly 750,000 square kilometers of water inside the national boundary. In a country of 26 square kilometers of land, the sea is not the threat to the territory. The sea is almost the entire territory. On the western side of Funafuti Atoll, there is a place where the land is still allowed to behave the way land here has always behaved. The conservation area covers 33 square kilometers of reef, lagoon, channel, and islet. 6 motu inside it: Tepuka Vili Vili, Fualopa, Fuafatu, Fuagea, Tefala, and Vasafua. Nobody lives on them. They hold about 40% of the native broadleaf forest left on the whole atoll, which matters more than it sounds, because that forest type covers barely 4% of the vegetation in the entire country. Green turtles nest on the beaches. The noddies breed on Fualopa. Coconut crabs work the leaf litter after dark. Surveys before the area was protected counted 76 indicator fish species, 141 food fish species, and nearly 150 mobile invertebrates. And in the same 4 decades that the national land area grew, some of those islets grew and others did not. Fuafatu gained, Fuagea lost, Tefala lost. Vasafua is not there anymore. It was on the charts. It had trees on it. After 2005, it stopped being an island, and what is left is a patch of reef flat where an island used to be. Which is the honest shape of the number from the beginning of all this. Tuvalu's land area increased by 2.9%. 74 hectares gained across the country. And inside that figure, 73 islands grew, 28 shrank, and 1 disappeared entirely. A national total can be true and tell you almost nothing about the ground under any particular set of feet. These islands are not holding a line. They are moving. Sediment is stripped from one end of an islet and stacked on the other. Shorelines migrate lagoonward. Land is subtracted here and added there, and the sum stays positive while individual places under individual houses come and go. That is not damage. That is what a reef island is. It is the only thing a reef island has ever been. The question is, what happens when the thing standing on it cannot move? There is one more sediment producer, and it is the smallest and the strangest of them. Foraminifera. They are single cells, not animals in any sense you would recognize, protists, individual living cells drifting or clinging on the reef flat, each one building a hard mineral shell around itself out of calcium carbonate taken from the water. Some of those shells are shaped like stars. On the ocean-facing platforms of atolls across the Pacific, one genus in particular, Baculogypsina, grows in enormous numbers on the algae and rubble of the shallow reef. Each cell is well under a millimetre across. Each one builds its spiked shell, lives its brief life, and dies. The shell stays. Waves lift those shells off the platform and carry them over the reef flat, and because they are light for their size, they travel further and settle in quieter water than the heavier coral fragments do. They pile up on the lagoon beaches. On some atolls, they dominate the sand entirely. So, pick up that handful again. Rubble on the ocean side, thrown there by storms. Sand on the lagoon side, made by parrotfish and by single cells you would need a lens to see. The two coastlines, 400 metres apart, made of different materials by different processes at different speeds. The country is an accounting entry between organisms that build carbonate and an ocean that removes it. Geomorphologists have a name for this. They call it the Carbonate Budget. On the income side, everything the reef produces. Coral broken into rubble by storms, sand ground out by parrotfish, shells of forams and mollusks, calcified algae. All of it generated on the reef and moved shoreward by waves and currents. On the expenditure side, everything the ocean takes back. Grains worn to powder and carried into deep water off the reef edge. Carbonate dissolved back into seawater. Sediment swept out through the passages and lost off the slope. For as long as income exceeds expenditure, the island exists. When it does not, the island does not. That balance has been running in Tuvalu's favour for thousands of years. It runs on one condition and one condition only. The reef has to be alive. A dead reef still breaks the waves for a while. It does not make sand. It does not repair itself. It does not replace what the ocean removes, and the ledger, quietly, starts running the other way. Everything about whether people can live on these islands, the width of the land, the depth of the lens, the height of the beach, the existence of the ground itself, is downstream of whether the coral is still growing. So, where does the ground actually come from? Walk to the ocean side of Fongafale and you will find a ridge. It runs along the seaward edge of the islet, a bank of broken coral, grey and bleached, the pieces the size of a fist and the size of a head, packed and settled and grown over in places. It is not a natural feature in the way a hill is natural. It has a date. On the 21st of October 1972, a cyclone called Bibe came across Funafuti. By 4 in the afternoon, before the worst of it, seawater was already coming up through the coral on the airfield and standing more than a metre deep. It was arriving from below, the way it always does here, only this time it did not stop. Through that night and into the next day, waves broke clean across the atoll. 90% of the houses and the trees on the islet went down. 5 people were killed, 2 adults, a 3-month-old child swept away by the water, and 2 sailors from boats wrecked in the lagoon. When it cleared, the island was flattened, and it was longer. Along the ocean side of Fongafale and Funafala, the storm had laid down a wall of coral rubble. 18 to 19 kilometres of it, 30 to 40 metres wide, up to 4 metres high in places. Something in the order of 1.4 million cubic metres of material. and that material had not been scraped off the beach and pushed inland. It came up from deeper water, off the reef slope, lifted by waves that had enough energy to move rock that size and carry it hundreds of meters. In a single night, one storm delivered more sediment onto that island than decades of ordinary weather. It did not stay where it landed. Over the following years, each successive storm reworked the ridge and pushed it further landward, towards the lagoon, the way a wave pushes a line of foam up a beach. The coarsest material was left behind as a lag on the reef flat, marking the line where it first came ashore. The rest was absorbed. It became part of the islets. 40 years later, when researchers measured every shoreline in the country, some of the growth they recorded on the southeastern side of Funafuti was Bebe, still arriving, still moving inland. In March of 2015, another cyclone tracked past and drove another surge across the atoll, and when the shorelines were surveyed afterwards, the net change was about 3.5 hectares of new land. The events that destroy the settlement are the events that build the country. The same wave, the same night. There is no version of this place where one comes without the other. Which brings us back to a hole in the ground, drilled in 1898. Charles Darwin had proposed in 1842 that an atoll is the ghost of a volcano. An island rises from the sea floor. Coral grows in the shallow, warm water around its edge. The volcano, dead and cooling, begins to sink, and the coral, which has to stay near the surface to live, grows upward as fast as the ground beneath it goes down. Eventually, the mountain is gone. The reef is still there, a ring of living rock standing on a column of its own dead, marking the outline of something that sank. It was a theory. Nobody had been able to test it. Between 1896 and 1898, the Royal Society sent 3 expeditions to Funafuti to drill for the answer. Charles Hedley, a naturalist from the Australian Museum, spent 2.5 months on the atoll in 1896 and wrote the first full account of it: the geology, the shells, the plants, the people. William Solis led the first boring, which failed at about 100 feet. Edgeworth David, a geologist from Sydney, led the second. The deepest bore was completed in 1898. It went down 1,114 feet, 340 metres. And it never reached rock. 340 metres of shallow water coral limestone, layer on layer of reef, all of it formed in bright water near the surface, all of it now hundreds of metres down. Later analysis suggested they would have needed to drill roughly twice as deep again to find anything volcanic. Darwin was right. It took until the 1950s and a bore through more than 4,000 feet of coral at another atoll to prove it beyond argument. But the answer had been sitting in the Funafuti cores the whole time. Under this country, there is no land. There is a sunken mountain, and on top of it, hundreds of metres of the remains of animals. And on top of that, 26 square kilometres of sand and rubble that the reef has thrown up above the waterline. And the top of that stack is young. Dating of the Funafuti core showed that the uppermost 26 metres of reef has grown in roughly the last 8,000 years. That is the reef racing upward as the ice sheets melted and the ocean climbed, keeping its living surface in the light, adding 26 metres of new rock in the time since. When the sea finally steadied, the reef kept producing, and the surplus, the rubble, the sand, the shells, had nowhere to go but up and inward. That is when the islands appeared. Not millions of years ago, a few thousand. Which means the ground here is younger than agriculture, younger than writing. In some places, barely older than the people who first stepped onto it. So here is the answer to the question this whole country poses. The ground is not sinking. It has been sinking the entire time. The mountain underneath has been going down for millions of years. The reef has never once stopped outgrowing it. Subsidence was never the danger. Falling behind was. And the ground is not solid either. It is a running balance between what the reef produces and what the ocean removes. Recalculated with every tide, settled violently every few decades by a storm. People live here because for 3,000 years, that balance has come out in their favour. Not because the land was safe, because the land was being made faster than it was being taken. Every single thing on these islands was built for that. The pit dug down to a lens that moves with the tide. The village that shifted along the shore when the shore shifted. The house on short posts that lets the water come through and go out again. The islet that migrates lagoonwood across its own reef platform and takes its coconut palms with it. The terms the land set were never hold the line. The terms were move with it. And that is the part that has changed. A runway does not move. 1,800 metres of asphalt laid across reclaimed swamp cannot migrate lagoonward when the sediment does. A seawall does not move. A concrete house does not move. And neither does a power station, a hospital, a fuel tank, or a road. A freshwater lens under a migrating island regenerates as the island rebuilds itself. A freshwater lens under a fixed, narrow strip, cut through with borehole pits and pressed on both sides by the tide, does not. That is why the wells went salt. That is why the pits stopped growing pulaka. Not because the country is disappearing. The country, on the measurements, got larger. Because the parts of it that people cannot pick up and carry are now standing still on ground that was never designed to. And the whole arrangement rests on a reef that has to stay alive to keep paying out. Every year on the beaches of the outer islets, something comes back to check. Green turtles, Chelonia midas. In Tuvaluan, Fonu. A female turtle spends decades at sea. She feeds on seagrass and algae across hundreds of kilometres of open water, and then, at some point in her 4th or 5th decade, she turns and swims back to the beach where she hatched. Not the region, the beach. How they do it is still not fully understood. The best evidence points to the Earth's magnetic field, that a hatchling reads the magnetic signature of the sand it crawls across on its first night, holds it for 30 years, and steers home by it. Which raises a problem no turtle has to think about, and every one of them solves anyway. The beach moves. On an atoll, the sand a turtle hatched on may sit 40 metres further inland by the time she returns. Some of it may be on the other side of the islet. The islet itself may have shifted across its platform. And still she comes ashore, hauls herself above the tide line, digs, lays, and goes back to the water. She is not returning to a place, she is returning to a process. The same one everybody else here depends on, worked out by an animal that has been doing it since long before the islands existed. In 1946, on Vaitupu, a man named Nelly Lefuka helped his island by a mountain in Fiji. He used to say that people without someone to lead them drift like logs in the current, carried but with no idea where they are going. He was talking about leadership, but he had spent his life on a landform that does exactly that. The rubble drifts. The sand drifts. The islet drifts across its own reef, slowly, in the direction the ocean pushes it. Everything here is in the current, and always was. For 3,000 years, the people on these islands moved with it, because moving with it was the only arrangement the land ever offered. Now there is a runway, a lagoon-side capital, a road with nowhere else to go, and 10,000 people living on 26 square kilometres of ground that is still being manufactured, grain, by fish, and by single cells, out on a reef nobody can see from the road. The land can still move. Nobody knows whether what has been built on it can. Thank you for travelling with us. Subscribe to keep exploring the places where the land decides, and we will see you on the next one.